Hello guys, I'm Dr. Ganesh. In this series, I am trying to explain or share my knowledge on machine learning. And we have been seeing different steps involved in machine learning process, starting from gathering data to cleaning or pre-processing data to selecting the right machine learning algorithm to evaluation parametrics and insights gaining and data visualization. We have seen all these steps in the previous videos, and here I would like to start taking one by one algorithm and then explain a little more. So a quick recap of different types of machine learning algorithms. They are primarily classified into two: supervised learning and machine unsupervised learning. Supervised learning is similar to learning from a classroom where a teacher teaches you what it is, how it is, and you are learning. So two major types of supervised learnings are classification and regression. Classification means from a set of non-labels, you want to classify a given input into one of them. For example, identify a color, identify a shape, identify whether this particular person has cancer or not, and things like that. Unsupervised learning is by looking at the environment, you just learn and do by yourselves. For example, clustering. Given two different items mixed together, you will be able to segregate them without anyone teaching you by looking at the color, the texture, the shape, and so on. That is clustering. Now, in this session, this is first part of the two video series on decision tree. Uh, Decision tree is used for both classification and regression. It is a supervised learning strategy. It's one of the most intuitive, popular machine learning algorithms used all along. So see a simple example. Am I hungry? No, go to sleep. Am I hungry? Yes. Do I have $25? Yes, go to a restaurant. No, buy a hamburger and then satisfy my tummy. So they are used for both classification and regression. It often mimic human level thinking, so it is very simple to understand. They actually make you see the logic, how you are interpreting data. It works for both categorical and continuous input and output variables. It works this way. It split the population or sample into two or more homogeneous sets based on most significant splitter. What decides the best division in the first place? The second best division in the second place, so on and so forth. Some terminologies involved in decision tree algorithm. It is a tree, so it starts with a root. A root represents entire population or sample, and this further gets divided into a few homogeneous sets with at least two sets. So you can see here the blue color node, which is the root. Splitting, it is a process of dividing a node into two or more subnodes. Decision tree node, when a subnode splits into further subnodes, that is called a decision node. And leaf or terminal node, where pruning is a very important process in decision tree algorithm. It's essentially, can we remove some subnodes and then uh, combine them to form a smaller subset, or a bigger subset with a smaller decision. So we will see it later. A small example, or a branch or a subtree. A subsection of entire tree is called a branch, and parent, a node which is divided into subnodes, is called parent of subnodes, and subnodes are child of the parent. Typical terminologies of any tree. Advantages of decision tree. They are very easy to understand because even with no analytical background, you will be able to understand a if and else logic, isn't it? And very useful for data exploration because it helps you identify more significant variables and relation between two or more variables. less data cleaning required. It requires very less data cleaning compared to some other techniques. It is not influenced by outliers and missing values to a very fair degree. And data types is not a constraint. It can handle numerical and categorical data. And it is also called as a non-parametric method. This means that decision tree have no assumptions about the space distribution and the classifier structure. Let's take an example. Let's say we have a sample of 30 students with three variables: gender, class, and height. 15 out of 30 play cricket in leisure time. Now I want to create a model to predict who will play cricket during the leisure period. In this problem, we need to segregate students who play cricket in their leisure time based on highly significant input variable among all three. So the first step here is to see which parameter can give me the best split in the first round. So you see here the snapshot, the picture. If I split them based on gender from the given input data, among females 2 play cricket out of 10, among males 13 out of 20 play cricket. Now split on height. Among people with less than 5.5 feet, 5 out of 12 plays cricket, and greater than 5.5 feet, 10 out of 18 plays cricket. Now by splitting on class, 11th class students are 14, among them 6 play cricket, and among the 10th class students 9 out of 16 play cricket. We can see that the best homogeneous set that it makes is with gender. The gender can split them better because it's highly unlikely that a female plays cricket, whereas it is highly likely that a male plays cricket. Other two parameters look quite tough for us to make a decision. So we'll come back to it later. Types of decision trees. There can be categorical variable decision tree or continuous variable decision tree. Categorical means in the above scenario of student problem where the target variable is student will play cricket or not. It's a category, yes or no. Continuous variable, for example, is to predict customer income based on occupation, product, and various other factors. How does a tree decide where to split? We already said it uses multiple algorithms to split a node into more subnodes. The creation of subnode increases the homogeneity of resultant subnodes. Or we can say that purity of the node increases with respect to the target variable. Decision tree splits the nodes on all available variables and then selects the split which results in most homogeneous subnodes. Let's look at this image below and think which node can be described easily. I'm sure your answer is C because it is very homogeneous, only single color, single type data. On the other hand, B needs some information and A needs maximum information. How that split happen? So in this example, C is a pure node and A is a very impure node. Now we can build a conclusion that less impure node requires less information to describe. And the more impure a node is, the more information we need to require to describe it. Information theory is a measure of to define this degree of disorganization in a system known as entropy. If the sample is completely homogeneous, then the entropy is 0. If the sample is equally divided, the entropy is 1. So let me repeat. The definition of entropy is a measure of homogeneity or a measure of impurity of the set of samples. Given a set of S positive and negative samples of some target concept, a two-class problem essentially, entropy of S relative to binary classification is minus P log P minus P n log n, log Pn. So some intuitions. Entropy is 0 if the outcome is certain. Entropy is maximum if we have no knowledge of the system. Now, S is a sample of training samples. P plus is portion of positive samples. P minus is portion of negative samples. Then entropy is nothing but minus P plus log P plus minus P minus log P minus. It's a measure of impurity. And if you know entropy, information gain is measures the expected reduction in entropy or uncertainty. So information gain is entropy of S minus sum of SV over S entropy of SV, where SV is a subset of S for which the attribute A has a value V. The first term in the equation is for gain is the just entropy of the original collection. So the measure of impurity in the original collection minus measure of impurity once we have a partition using an attribute A. And see who gives you the best gain and select that as a feature to divide. It's simply the expected return in entropy caused by partitioning the X samples according to its attribute. It is the number of bits saved when encoding the target value of an arbitrary member of S by knowing the value of attribute A. Now let's go back to our student's example and calculate entropy for different nodes, starting with the parent node. There were 15 students who play cricket out of 30. So minus 15 divided by 30 log 15 divided by 30. And then 15 who does not play cricket. So 15 over 30 log 2 15 over 30. This is essentially 1, isn't it? So here 1 shows that it is an impure node. It's a very homogeneous distribution, very difficult for us to do any prediction. Now let's take split for gender. So entropy for female node. Out of 10 students, females, only 2 play cricket. So 2 over 10 minus the negative, which is 8 over 10. So 0.72. And for male, 13 over 20 minus 7 over 20 leads to 0.93. Similarly, entropy for the split gender is weighted entropy of subnodes. So 10 over 30 times 0.72 plus 20 over 30 times 0.93, which is 0.86. Now entropy for the class 11th node. So by split by class, similarly we get a value and we get it as 0.99. So above you can see entropy for split for gender is lowest. So the impurity is lower. So the tree will split on gender and we can derive information gain as 1 minus entropy. How much more knowledge we can gain by splitting that particular factor? I suggest you to pause the video here, understand these terminologies through this example and then proceed further. And with that, let me thank you. We will continue to have discussion on decision tree. One of the popular algorithms, we will take it up and then look through. But here the idea was to give you a basic introduction to different terminologies involved in a decision tree. How do you make a decision, so on and so forth. Feel free to give comments, subscribe and share.